Good morning, good afternoon, good evening. I'm Dr. Alvin Marcelo, and I will be speaking briefly on the importance of data quality in healthcare and a simple strategy for teaching the same for frontline community health workers. So let's start by understanding the data information knowledge lifecycle. Your dictionary.com defines data as facts or figures or information that are stored in or used by a computer. In healthcare, we are drowning in data. This is something we do with our eyes closed on almost a daily basis when we take history and perform physical examination on our patients. This is almost intuitive for us. Examples of data in the medical chart might be age, sex, and the latest hemoglobin A1C result, or your sodium, but data by its lone self are not immediately useful. When we put data together, they become information. In this example, we put together some data we collected from a patient in the emergency room. He's a 24-year-old male with a 3-day history of epigastric pain, later transferring to the right lower quadrant. On PE, there is direct and rebound tenderness on the right lower quadrant. This group of data, now called information, will be meaningless to a high school student, even if he can read it. You know why? Because the high school student has not yet gained knowledge that this information correlates strongly with the diagnosis of acute appendicitis. But the medical clerk and intern will see this immediately. Knowledge occurs when information triggers another concept, in this case, acute appendicitis, which is not specified in the original set of data. The medical student's ability to infer this knowledge is their doorway to the practice of medicine. That's why we encourage you to keep looking at as many patients as you can so you can recognize the different patterns and variations related to a particular medical condition. But it doesn't end there. Knowledge without action is meaningless. Depending on your role in the medical team, you can take action on the information and knowledge. While the same knowledge was triggered, our actions will vary depending on our responsibilities in the team. For example, the student can already inform the patient not to eat or drink in preparation for the operation. The first-year medical resident can already start an intravenous infusion to start hydrating the patient while they are on NPO. The surgical resident can start requesting for lab exams while securing a slot in the operating room. And finally, the senior surgical resident performs the appendectomy. This orchestration becomes possible because each team member was able to gather the same quality data, compose them into information and knowledge, enabling them to act as a unit. The way health professionals process information is left to right. We construct or build towards our actions by collecting the right data that later become information and knowledge, allowing us to take appropriate action for our patient. On the other hand, when you are building an information system, for example, an electronic medical record, you should start with understanding first what actions health professionals take, and then deconstruct them into the knowledge, information, and data that should be present in the EMR. The construct leg is the bread and butter of the health sciences, while the deconstruct leg is the purview of the health information sciences or health informatics. So let's now drill down on data, as we have seen that they are the building blocks of an information system. If data are facts, then they should have the following characteristics: accuracy, validity, integrity, completeness, consistency, and timeliness. What's important is that when these characteristics are compromised, data ceases to be factual and its value is degraded. Can you imagine the horrors if the direct and rebound tenderness of our sample patient was in fact at the left lower quadrant rather than in the right? The surgeon would be creating an incision at the wrong place for diverticulitis on the left. Good data quality contributes to good patient outcomes, and poor data quality can result into disaster and injury. Most other frameworks for data quality emphasize these characteristics. but not many describe the process by which these characteristics can be achieved. This website shows a six-step process in achieving data quality. The process is continuous because deterioration of quality still happens, especially when parts of the data collection involves humans, like history taking and physical examination, but subsequently encoding the wrong thing into the medical chart. Quality assurance, therefore, is a non-stop process. You define the business goals, you assess the existing data state, analyze the results, then develop improvement plans, implement solutions, and set up control processes. Interestingly, the deconstruct and construct legs of the DIKA lifecycle maps very well with the six-step quality improvement process. Finally, I would like to share with you a simple mnemonic on data quality that you can use when giving public health lectures to community health workers like RBHWs. With the passage of the Universal Health Coverage Law, we are at the verge of electronic medical records. This will help them remember the characteristics as they start encoding data into the EMRs. A for kumpleto, T for tama, P for napapanahon, N for nababasa, and N for nagagamit for Katipunan. Thank you, and if you have queries, you may reach me at Twitter at @amarcelo. For further readings, you can go to this website and download Improving Data Quality, a guide for developing countries. Thank you very much, and I hope you have a nice day.